Hello, my name is Caden, and today I'll be presenting research on how working memory capacity influences attentional control. I'll be discussing two original empirical studies, one by Kane and Engel from 2003 and another by Fukuda and Vogel from 2011. Together, these studies show how differences in working memory shape our ability to focus, filter distractions, and maintain task goals. What the cognitive topic is, why it is important in cognitive psychology, how your two articles relate to each other. The cognitive topic for this presentation is relationships between working memory and attention. Working memory allows us to hold information in mind, while attentional control helps us stay focused on goals and resist distractions. Both of the studies I'll explore how the capacity of a person's working memory influences different forms of attentional control. Kane and Engel look at goal maintenance during a Stroop task, while Fukuda and Vogel examine distractor filtering during a visual memory task. Oh, sorry. Based on the theory that working memory supports goal maintenance, authors ask, does high working memory capacity reduce Stroop interference? But the hypothesis is high WMC individuals show smaller Stroop effects due to better goal maintenance. The first article by Kane and Engel asked whether people with higher working memory capacity show better attentional control. Authors focus on the Stroop task, which requires overriding an automatic reading response. Their central question was whether high working memory individuals would show smaller Stroop interference. Their hypothesis was that working memory support goal maintenance, so people with higher capacity should be better at staying focused on a task goal and therefore experience less interference. The participants were college adults, and the task was classic color word Stroop task. To test this, the researchers first measured each participant's working memory capacity using standard span tasks. They then divided participants into high and low working memory groups. All participants completed the classic color word Stroop task where they had to name the ink color of a word that could either match or conflict with the word's meaning. The independent variable was working memory capacity, high versus low. The dependent variable is the level of Stroop interference, which is the difference in reaction times between congruent and incongruent trials. This task measures cognitive control because it requires inhibiting the automatic tendency to read the word instead of naming the ink color. Kane and Engel found a clear difference between the groups. High working memory participants showed significantly smaller Stroop interferences compared to low working memory participants. Low capacity individuals were much slower on the congruent trials, meaning they struggle more to override the incorrect automatic response. This pattern supports the idea that working memory capacity helps people maintain the task goal and resist interference. The key figure in the paper shows a clear gap between the two groups' interference scores. Hypothesis was strongly supported. These findings support the author's hypothesis. Kane and Engel concluded that working memory plays a direct role in attentional control because it helps maintain goals in the face of distraction. In other words, when people have more working memory resources available, they're better able to keep the task goal active and prevent automatic habits from taking over. The second study by Fukuda and Vogel examines a different aspect of attentional control, the ability to filter out distracting visual information. Their main question was whether people with higher visual working memory capacity are better at ignoring irrelevant items. Their hypothesis was that high capacity individuals should show less disruption from distractors and should be more selective in what they allow into working memory. These participants were young adults. In this study, participants completed a visual change detection task. They were shown displays of colored squares and asked to remember them. Some trials included distractor items that they were supposed to ignore. Participants were again divided into high and low working memory groups based on their memory performance. The independent variable was memory capacity group, and the dependent variables were accuracy on the task and neural markers associated with distractor suppression. The task measures visual working memory because participants must encode, maintain, and complete visual information while ignoring irrelevant stimuli. The results show large differences between the two groups. High working memory participants were more accurate when distractors were present, while low working memory participants showed substantial performance drops. Neural data confirmed this pattern. High capacity individuals showed lower ERP responses to distractors, meaning they were filtering them out. Low capacity individuals perceived distracting items almost as much as the target items, which reduced their performance. These findings supported the author's hypothesis. Fukuda and Vogel conclude that working memory capacity determines how effectively a person can filter out relevant information. They argue that the ability to exclude distracting items is the major reason why some people have higher memory capacity in the first place. When we compare both studies, a clear pattern emerges. Individuals with higher working memory capacity consistently show better attentional control. Kane and Eagle demonstrated this with the verbal truth test that required goal maintenance. Thank you for your time. I'm Kaden, and this was my presentation.